Hi, this is Gleb Bakhmutov. Let's talk about page objects. In this video, I will show how the same algorithm that solves Wordle game works to solve different implementations of Wordle, including the ones that are very different. Here's an example where we use page objects to abstract all interaction with the page itself. In this spec, notice we're loading the fixture of words. We save it as an alias, and then we actually start interacting with the game. We control the clock to make sure we know the word. We check the solution. And then instead of going to the page and, for example, closing the pop-up, we use an object and call a method close. Now this object comes from our page file and it provides a couple of page objects, start, playing, and solved. And I like using different page objects for different stages of a game, the start stage, the playing stage, and the solved. Let's look, for example, at the start object. All it has is a single method. Notice there is no state, no data. It literally abstracts commands that, for example, find the element, click, and then wait for animation to finish. Similarly, with solved page object that closes the final solution model, does the same thing. It tells us what it does, interacts with a button, interacts with another button. Pretty simple. Let's see this in action. Think control the word is spec. Okay, so notice how we closed the first pop-up, we played the game, and then we closed this statistics pop-up. Yeah, all using page objects. Now the cool thing here is this middle part. It's easy to call the method to close the pop-up. What about actually playing the game? So in addition to page objects, I use something that I call, in this case, a solver. Now this particular function is my algorithm for solving the game. It can use Cypress commands, but to access the page itself, it uses the past page object, right? So for example, when it tries the next word, it uses the page objects to enter that word, right? Which will enter it right here on the top, okay? So right about here, it enters the word. Now the game will provide the information about each letter, so we have to get it from the page, and that's where we use the page object itself, using page object get letters. And we actually check the page object in the solve function before we start using it. Make sure the page object we passed actually has everything we need. In between those, entering the word, getting the information, we update our word list, all the pure functions that deal with the logic of a game and not with a page. Now let's look at the actual implementation. So enter word was a simple utility function that I've written in my utils function. Okay, just uses get key down event. And get letters is something that's specific to this implementation of a game where it finds the word, finds the tiles, and then for each tile collects the letter and the status like correct, present, absent. Now this works in the original Wordle. The same page object works when we, for example, try to solve a greener Wordle where every word has something to do with the environment and the climate crisis. Notice if we look at the spec, we import the same page objects and the solve. We modify how we extract the words because they're slightly different in the bundle, but then we use the same start, solve, solve, close, and we can, of course, insert additional Cypress commands. Now, why is this so cool? Well, here's a version of Wordle that's completely different. It's implemented from scratch. In Vue, the structure of a page is very different, right? So we need to abstract those parts in order for us to play the game using the same solve algorithm. Now let's look at Vue Wordle spec. Now notice right here, when we play, we're using the same approach. Now this particular version doesn't have a pop-up at the beginning, but it does play the words. And so we're passing to our solve, which is the same solver, a different page object, right? And then let's look at this implementation. We have to change how the enter word is implemented. Instead of key down, it uses key up. When we get the letters, There is a structure and the class names, and everything it does is slightly different. So we have to kind of adapt our logic to extract that for each letter. But once you extract, it's the same information that goes into the solve and allows us to determine the next word and continue. So this is how useful the page objects are if you have multiple implementations, for example, of a game using different DOM structure, different elements, class names, and so on, and yet you keep the algorithm itself, the solver, independent of a page implementation.